Good morning, one and all present here. A warm welcome from Department of Management Studies, University College of Engineering, Anna University BIT campus, Tiruchirappalli. Dear participants, today is the last day for our webinar on data analysis using SPSS. The resource person is Dr.M.Sivagnanasundaram, Associate Professor. Since this is the last day, small introduction and an instruction to the participants before starting our session. So today's session is related to non-parametric test, and after the session you will have a valedictory address from our Dean, Dr. T. Sedil Kumar, followed by an assessment test as well as a feedback form which will be sent to you through Google Forms. There will be a time frame so that you can complete it as much as possible, as soon as possible, and submit it. And there will be a vote of thanks, and finally we will conclude based upon the feedback session. So that's about today's plan. Thank you one and all. I invite the resource person, Dr. M.Sivagnanasundaram, to start the show. Professor?
Yeah, thank you.
You can continue.
Yeah. So, good morning, one and all. Today's session is about non-parametric tests. So, for whatever the test that we have seen is known as parametric test, the condition for doing parametric test is the data need to be continuous. Unless otherwise the data is a continuous data, otherwise scale data, which could be of type interval scale or ratio scale. We cannot perform parametric test. So, in case if your data is of categorical data or nominal data and ordinal data, then we call for that particular data, what the test that we are going to use is non-parametric test. So, under the non-parametric test, chi-square is the test that is predominantly used. We are going to discuss, after discussing chi-square test, what are the different types of non-parametric test in detail. To start with, we are going to do chi-square test, the non-parametric test. There are two types of chi-square tests. One is testing the relationship that is called test of association, and another one is called goodness of fit. So we have two types of chi-square tests. One is test of association. Is there a relationship between two variables, in fact categorical variables, and the other set of tests is known as goodness of fit test. So to start with, I'm starting with goodness of fit test. Look at the problem. Hope you can read the screen. I've given the first problem as a machine has a record of producing 80% excellent, 17% good, and 3% unacceptable parts. After extensive repairs, a sample of 200 produced 157 excellent, 42 good, and 1 unacceptable part. The question is, have the repairs changed the nature of the output of the machine? So the level of significance is 5%. So I have to check whether the repair is effective or not. If the repair is effective, the machine should be conforming to the standard of producing 80% excellent and 70% good and 3% unacceptable parts. So in order to check that, I'm going to run a chi-square test. Why I'm doing chi-square test is that it is count. For example, there are 3 classifications: excellent, good, and unacceptable. What is that I have is the number. So in the sense, in your data set, actually, you should have only, if you are coding, for that example, if you are coding excellent as 1, there will be only 1 column in the data set. You should be entering the data 157 rows as 1, 1, 1, 1, 1, 1. And then if you are coding 2 as good, there will be 42 rows as good. And 1 row unacceptable part, if you are coding that as 3, there will be 1 row mentioning 3. So totally in your data set, there will be 200 rows, of which 157 rows would be of 1, and 42 rows of 2, 2, 2, 2, since 42 rows containing 2, and just 1 row containing 3, which means unacceptable part. This is how your data set is supposed to be. But that will be time consuming. If I have to write 200 times, 150 times 1 and 42 times 2 and 1 time, that's easy. 1 time writing 3 is easy. But writing or entering the data 157 ones and 42 twos is very, very difficult. So in order to overcome that, there is a shortcut in SPSS. I can enter the data in the simplest possible way. So let me, for entering this data for SPSS, rather than conventional way of doing, I am trying to do the simplest way, which is quite easy. And we can make SPSS also to understand. One is the nature of the problem is excellent, good, and unacceptable. Excellent, good, and unacceptable. So we call that as nature or quality. We can say quality. We'll call the variable quality. Second variable I'm going to call as count. So what I'm doing is, you can see the SPSS screen, right? You can see the SPSS screen, right? Rema? Perumal?
Sir?
You are seeing SPSS screen, right?
Yes, sir. Yes, sir. Visible, sir.
It's visible.
So I'm saying the first variable is quality, second variable is count. I'm giving the values. We said 1 as excellent. 2 as good. 3 as unacceptable. Okay, so now I'm going to data. So I'm writing 1, 2, 3. 157, 42, 1. Now you see that how I have entered the data. So excellent, in the Word file I have shown you, excellent is 157 and good is 42 and unacceptable is 1. So I have entered the data as given, but this is not the way we are supposed to enter the data. Rather, what we are supposed to do is, we have excellent as 1, right? So you should have 157 rows. Till 157, you have to type 1. Then you have to type 2, another 42 rows. And then one row will be containing 3. So that is how you're supposed to enter the data. That is time consuming and cumbersome. So I'm making it simple, feasible way. Okay. So what is that I expect the machine to produce? What is that given in the problem is the machine is expected to produce what? The machine is expected to produce 80% excellent, 17% good, and 3% unacceptable. 80, 17, and 3. This is the expected frequency. We call that this is the expected frequency. And in the sample of 200, what we have seen is 157 excellent and 42 good. 1 unacceptable are observed frequencies. So what I'm going to do now is whether your chi-square statistic is computed based upon observed frequencies and expected frequencies. O minus E squared divided by E squared. That's what you are, how you compute the chi-square statistic. So keep this number in mind, 80, 17, and 3. So let me go to 80, 17, and 3 here. Okay. So how to do chi-square test? Before doing chi-square test, in order to make SPSS to understand, instead of writing once 157 times, I have made this format. So I have to make SPSS to understand I have did this. For that, there is an option called weight cases. Data, under data, there is an option called weight cases. So I'm weighting the cases by what? One count. This counts, instead of writing 157 times once, I have written in one single row. Please treat this as 157 rows of 1. That is what I'm informing SPSS. Click OK. Now SPSS will understand this guy has written 157 once in this format rather than writing 157 times. So now analyze. To see the non-parametric test. Analyze under non-parametric test. What we are going to do is we are going to use chi-square test. The non-parametric test, I have chosen chi-square test. What is my test variable? Count is my test variable. Count is my test variable. And what are the values? You remember the machine is supposed to produce 80% excellent, 17% good, and 3% as unacceptable. So you have to write the values in the ascending order. In the sense, 3% is unacceptable, right? So 3% is 0.03. And then 17% is 0.17. And then 0.8.
Sir, screen stuck in Word file, sir.
Okay. Okay, let me repeat. So first what I have to do is I have to inform SPSS that I entered the data in this format. So for that data weight cases, there is an option. Option is here, that is data. Last option you see weight cases. The moment you click on that, you'll get a tab like this, table like this. What I do is I'm weighting the cases by, this is how it will appear first, and then I'm moving weight case by count, because this is what count is. Click OK. By this, what happens is that SPSS understand, instead of entering the data in a conventional way, I have changed this. So now it will understand 150 times, 157 times ones are there. So now I'm doing non-parametric test, chi-square. Chi-square, my test variable is count. And what is my expected frequency that is given in the problem? You should write it in the ascending order. 3% is unacceptable. 17% is good. And 80% is excellent. This is what I expect the data. Expect the frequency to be. Let's see the output. You see that observed frequency, our sample size is 200. How many we expect to be unacceptable? It is 3%. 3% of 200 is 6. That is what expected frequency is coming as 6. Then 17% of 200 is 34. We expect 34 products to be of good. And 160, that is 80% of the sample, we supposed to see that as excellent products. So that is what expected frequency: 17%, 3%, and 20%, 80%. I'm sorry. This is observed frequency: 142 and 157. Remember, we entered in the data set as observed. This is expected. So based on that, chi-square statistic is computed, which is 6.105, and we have to look at the significant value. The null hypothesis is there is no difference between observed frequency and expected frequency. There is no difference between observed frequency and expected frequency. So what does it mean? If the machine is capable of producing as expected frequency, the repairs were extensive. Repairs were good enough. What is the null hypothesis? There is no difference between observed frequency and expected frequency. The null is getting what? Rejected, because it is less than 0.05. So there is no difference is rejected. Then what does it mean? The machine is capable of producing as expected. Then the repairs are effective, because the repair is not effective is getting rejected. So I can say that the repair is effective, the machine is conforming to the specification. Any clarifications?
Yeah, sir. Hello.
Yeah.
Sir, audible, sir?
Audible.
Sir, question from Priya. How we can understand value in chi-square test?
What do you mean? See, what kind of question is this, Rema? How do you understand value in chi-square test means what? What value? Everything is value here in the table. Please ask Priya to be specific. How many values you are seeing here? Everything is value.
Next question from Pratik, sir. In null, there is no association between observed and expected. This cloud also be null?
So there are two types of test I told you. One is test of association. Another one is goodness of fit. What we are doing is goodness of fit. We are not checking the association, whether the expected frequency matches with observed frequency. This is called goodness of fit. The null hypothesis here is the machine is capable of producing as desired after repairs. In a sense, no difference between the observed frequencies and expected frequencies. Next question.
Typing, sir.
That's it. Typing. Still questions coming?
No, sir.
Okay. So I'll take one more example in the same category, which is called goodness of fit test. We'll do one more. I'll go to the Word file now. You guys see the Word file?
Yeah, sir. Visible, sir.
Yeah, suppose we used to test the null hypothesis that Dr. Siva gives equal number of A's, B's, and C, D's, and F's as final grade in his MR course. The observed frequencies are slightly modified. Okay. So the observed frequencies are A is 6, B is 25, C is 50, D is 10, and F is 9. So what is my observed frequency? A is 6, B is 25, C is 50, D is 10, and F is 9. F grades are 9 students have got F grade. And whereas what is my observed frequency? Sorry, expected frequency? There are 5 letter grades are there: A, B, C, D, and F. If I say all are equal, all supposed to be 20, 20, 20, 20. The frequency would be expected frequency is 20, 20, 20, 20 for all the grades. So how to test that? Sorry, did I read say? You're seeing the screen, right?
Yeah, sir. Now visible.
SPSS, yeah. So first one is grade, second one is count. First one is grade, second one is count. So I'm going to data view. Sorry, I have to define grades, right? Values. One is A, because SPSS will not accept any string. 2 is B, 3 is C, 4 is D, and 5 is F grade. Okay, let's come to the grade. 1, 2, 3, 4, 5. So what is the numbers? Observed frequency 6, 25, 50, 10, and 9. 6, 25, 50, 10, and 9. So this is the frequencies that I have got. This observed frequencies for the letter grades. That is A grade. How many students have got? 6 students have got A. 5 students have got B, and 50 students have got C. 10 students have got D, and 9 students have got F. How to do the test? Highlights. Non-parametric text. The test variable is count. Since I'm expecting all to be equal, there is an option you see here, all categories equal. I'm leaving that as default. In the earlier exercise, I have given the values, selecting this, and I have given the values. In this, I'm treating all categories equal. So since all categories equal, I need not to give the values. Otherwise, if you are taking this, you have to give 0.2, 0.2, 0.2, 0.2, 0.2. So I'm treating all categories equal. Let's click OK. What is the problem? It is not showing me the results. I just made a small mistake. I have to wait cases. Otherwise, SPSS will treat all pertaining to single category. So what I supposed to do? So A I supposed to write, for example, 1 I supposed to write 6 times. 6 rows will be 1, whereas I am writing this way. So I have to inform SPSS that I'm doing this, wait cases by what? Count. Now you run the analysis. Otherwise, non-parametric chi-square. Yeah. Count is a test variable, all categories are equal. Click OK. Now you will get the results. Yes. You see that expected frequency is 20, 20, 20, 20 because I have 5 letter grades. I expect all grades to be equal. And this is the observed frequency 6, 9, 10, 25, and 50. So, what is null hypothesis? There is no difference in the observed frequencies and expected frequencies. The null is getting rejected. So there is a difference in the frequencies. In the sense, it is not matching the curve that I'm expecting, the distribution curve. So I will say that there is a difference in the grading. The gradings are not equal. Because the grading should be equal as per the frequency expected. But what happens is that the observed frequency is not matching the expected frequency. So I can conclude that there is no difference, null hypothesis getting rejected. So there is a difference in the frequencies. In a sense, the grades are not equal. That's what the conclusion. Can we move on?
A question from Dhanalakshmi Nadar. How do one conclude the result by seeing the significant value? Is it alpha value less than significance value? Then we reject null hypothesis.
Your alpha value is nothing but significant value.
Okay.
The significance is nothing but alpha.
Okay, sir.
There is no difference between alpha and significant value. One and the same.
The next question from Bhuvesh. Chi-square, how to calculate manually?
Refer any textbook that will help you. This is SPSS. Data analysis. The workshop is data analysis using SPSS.
A question from Mahalakshmi. Sir, how grades are not equal? Could you please explain again?
What do you mean by equal? What do you mean by equal in first place? The number of students, those who have got grades should be equal. That's why we are saying grades are equal. Number of students, the grades are equal. It is actually number of students that who got the grades are equal. In the sense, number of students got A grade is equal to number of students got B grade, number of students got C grade, D grade, and F grade. That is the hypothesis. The grade distribution is equal. That is the hypothesis that we are testing. The observed frequencies are 6, 9. How many students have, if you look at the question, how many students are getting A grade? 6 students has got A grade, 25 students have got B grade, 50 students have got C grade, and 10 got D, and 9 got F. Had it been equal, A would be 20, number of students got A would be 20, B would be 20, C would be 20, D would be 20, F would be 20. If you ask a question like this, it is very much visible. A is not 25 here in the observed frequency. Sorry, 20 here. None of the grades are equal to 20. So I can simply conclude that the grades are not equal, isn't it? This is a question to everyone. Here, I am expecting number of students getting A grade, 20 students, B is 20 students, C is 20 students, D is 20, F also 20. But when I take a sample and when I am observing in one class, number of students I have given A is 6, B is 25 students, C is 50 students, D is 10 students, and F is 9 students. So how much total? 25 plus 6, 31, 31 plus 50, 81, 81 plus 1900. Of the 100 students, A is supposed to be 20 students, but A only 6 students have got it. If the grading pattern is equal, everyone should be, in each grade there will be some 20 students. So I can simply conclude by looking at the data that the grade distribution is not equal, isn't it? Yes or no? Just float a survey, Rema. How many people are saying yes? How many people are saying no? The question is, I'm just observing the frequency is supposed to be 20. The sample, the frequency is 6. And for B, I expect 20, it is 25. C, I expect 20, it is 50. D, I expect 20, it is 10. If I expect 20, it is 9. So I can simply conclude that frequencies are different. Yes or no? Why I have to do a chi-square test? And something is evident from this one.
Sir, 50%, 80% of yes, sir.
There is no need to do such a test, right? That's what they are saying.
Yes, sir.
Right. So we are all back to square one, day one. After 5 days, we have to start everything from scratch. This is a sample. I have taken a sample and I'm trying to study whether my grading pattern is equal. So this is a sample. Based upon that, I'm studying the population. In the sense, at one point of time, I may not be following the distribution. But if you study repeatedly my grading sections are grading over 3 years or over 5 years, if you look my gradings, the gradings would be equal. I'm making sense? So here we are taking one sample and trying to study about what would be my grading pattern over the years. The population for me is, for example, if I'm teaching for the last 20 years, what is the grades that I have given over 20 years? What is that sample that you are taking is one sample, one section sample, and you are trying to find out whether I am giving this kind of grades over the years. Am I making sense here? You guys are able to follow. You are deciding about the population based upon a single sample. So if you conclude that the gradings are not equal by one single sample, you are making a wrong decision. For example, I want to find out the height of the students in a class. For example, in the class, there are 90 students. I take 30 samples of 3 each. 30 samples of 3 each. A sample contains 3 students. So there is a chance that all the 3 students are shorter or all the 3 students are taller. If I take a sample from the first bench, the 3 students would be a shorter students. If I take the same 3 students from the last bench, all the 3 students would be taller. So in both ends, I'm making a wrong decision because I'm making a decision about the average height of the class based upon the sample that I have taken. There is a chance that I may take a sample mean. There is a chance that I can get a sample mean which is lower than the class average. There is a possibility that I can get a sample mean higher than the class average. So here I'm studying about the grading pattern of Dr. Siva. The problem is I'm deciding based upon one single sample. I'm not studying about his history. Over the 20 years with the population, over the 20 years has he taught at least 100 MR classes. If I look at the grades, that is going to take too much of time. So what I'm doing is I'm studying based upon one sample. 1 year I randomly take data and then try to understand what is his grading pattern. Is that clear to you guys?
Yeah, sir.
Okay. Yes or no? I don't know.
Yes.
Yeah, it is in a real environment. I can explain further, but there is a little difficulty in webinar sessions. There is a difference between live sessions and webinar sessions. If you ask me, is there a statistical difference? I would say that definitely yes. Yeah. So just assimilate that. Otherwise, we would not be doing any statistical tests. Statistical tests are done. As I told you in the first class, it's inferential statistics especially. I'm drawing the conclusion about the sample based upon the, population based upon the sample. I infer about the population based upon the sample. Here the grading is one sample, one class sample. Based upon that, I am deciding about my total pattern. Okay. So there is a next type of analysis which we call as test of association. The test of association is going to test the relationship between two variables. But the first two that what we have seen is goodness of fit. So next two examples that we are going to see is called test of association. Look at this problem. Am I sharing the Word file right now?
No, sir.
No, sir.
SPSS only is visible.
Yeah, I'll show the Word file. Right. Can you see the Word file now?
Yeah, sir. Now it's
Yeah. In a study, students were grouped together based on high school graduation status and then their socioeconomic status, SES. Given the following data, determine whether high school graduation is independent of socioeconomic status. Using contingency table method, find out is there a relationship between high school graduation status and socioeconomic status. This is called test of association. So someone is asking there is no association. You can use the word no association only in this type of chi-square test, not the earlier one, because the earlier one is you are looking at the goodness of fit, whether the expected frequency and observed frequency are matching. Here we are looking at is there a relationship between these two. Here you can use the word there is no association. You should be very, very careful. You cannot simply use no association everywhere in all chi-square tests. Okay. How to do that? You understand the problem? There is no graduation. That is, whether a person is graduate or not, and whether what is their socioeconomic status. Based upon that, we create a contingency table. Of the total sample of 40, no graduate is 15, graduate is 25. And then people coming from low socioeconomic status is 20, high economic status is 20. This is the distribution. So I want to find out is there a relationship between high school graduation and economic status. This is what the test I have to do. So low, more, 1. Okay. So now I am creating a data set. Before that, let me take a note of it because I'm changing the screen. Low, high, no, yes. 10, 10, 5, 15. Okay. So now I'm moving to SPSS. Please tell me if the screen is not visible.
No, sir, not visible.
I'm going to share the SPSS screen. Yes. So you're seeing an empty screen now?
Yeah,
Yes,
sir,
sir.
now it's visible.
So first variable I'm taking is whether someone is graduate or not. So graduation. Second variable I'm taking SES or socioeconomic status. Socio-eco underscore status. So graduation, I can give values 0 as no grad, 1 as yes grad. Since he is a graduate. Similarly, socioeconomic status 1 as low SES, 2 as high SES. And I need another variable, third variable, count. Okay, so 1, 1. How many? 10. I'll explain what is that 1, 1. 1, 2 is also 10. Then 2, 1 is 5. Then 2, 2 is 15. Now you see here. So what is that? I have not defined it properly. So that variable B. Socioeconomic to high, okay. Okay, I have written values 0 and 1, whereas there it is 1 and 2. So change that. One is no grad. Was grad. Yes, grad. Okay. So no grad, low economic status 10. No graduation, high economic status. What is that I have in the question? No graduate, low economic status. Low high should be 5. Low high should be 5. This is 5. No graduation, high economic status is 5. And then S graduation, low economic status is S. Okay, so if you look at the data set, let me share the data set first. What is that I have in Word file? I'm just reproducing the table there. So this is what I have. You see here, no,
Yes,
no and low 10, no and high 5. So similarly, whether it is coming in SPSS also you have to check while entering the data itself. Otherwise, if you're entering the data wrongly, it will be going for a toss. Right. So no and low 10, no and high plus 5. Yes, no, is 10 and F got a 10. So next I have to tell SPSS that it is a data weight cases. Why I am weighting cases? Otherwise, no grad and low should come for 10 times. And no grad high, I have to type, this way. 1, 1, I have to repeat for 10 times. And 1, 2, I have to repeat for 5 times. 2, 1, I have to repeat for 10 times. Instead of that, I'm doing it in a simple way. So I'm weight cases. So when I'm doing this, I have to tell SPSS that I have modified this. So weight cases is done. Now I have to analyze the data. Analyze. You cannot use non-parametric test now because if it is following goodness of fit, then you can use chi-square from here. For this type of association test, I have to go descriptive statistics under cross tabulation. Under cross tabulation, I'm moving socioeconomic status to rows and graduation to columns. Then statistics, I'm taking chi-square. Oh, 8 cases by graduation, 8 cases by count. Okay. Now analyze. Let me repeat the analysis. Please follow. Analyze descriptive statistics, which you have cross steps. I'm taking, this is how moment you click on it will come. I'm taking socioeconomic status to the rows and graduation to the columns. And I'm selecting statistics, under which I'm taking chi-square. Click continue, click OK. Now you see that whether this table that we have created is matching 10, 10, 5, 15. Socioeconomic status low, high, graduation no, yes. You can refer the word file. I will show the word file now. You see here 10, 5, 10, 15. So low economic status, high, graduation, no graduation is graduation. The same thing has come here also in SPSS. See? Okay. So now you have to look at the chi-square test and you have to look at the significance. What is that significance? What is the hypothesis? There is no association. There is no association between the variables. When you check there is no association, and the hypothesis is that there is no relationship. So whether your null is getting accepted or rejected, if your hypothesis significant value is less than 0.05, your null is getting rejected. Here null is getting accepted. So what does it mean? It is greater than 0.05. What does it mean? There is no association between socioeconomic status and the graduation. Is that clear?
Yes, sir.
Is there any doubts? There are no doubts. Let me run one more on the similar exercise. You see here. Housing quality and poverty. Housing quality 1 is low, 2 is high, poverty 1 is low, 2 is high.
The screen stuck in.
Yeah, I'll show you.
Sir, question from Kavya. What type of condition for chi-square test?
There are two conditions for chi-square test. One is you want to test the association between the variables, like the one that we did now. Another one is to test the goodness of it. And your variables are categorical variables. Then, is there any other question?
No more. Sir.
Right. So, am I sharing the word file now? Yeah. Can you see the word file now?
Yes, yes,
Yes, sir.
yes.
Yes, sir.
Yes,
Is
sir.
there a relationship between housing quality and poverty? So assume 1 as low and 2 as high. Similarly, poverty level is also 1 as low, 2 as high. Since low is 11, low high is 4, and low is 27, high is 15. So find out, is there a relationship between, or is there association between housing quality and poverty? Maybe you can do this as an exercise. You can tell me, is there an association between these two? So how to enter the data? You have to straight away enter the data in SPSS like same format. First row housing quality, first column housing quality, second column poverty level, third column count. Then what you're supposed to do is data weight cases, and then do the cross tabulation under descriptive statistics, select the chi-square test. Tell me, is there an association between housing quality and poverty level? Thirmal, is that okay? People can do and then tell, is there a relationship?
Yes, sir.
Yes or no, they are, yeah. Because it's a simple exercise, they can do it and quickly say.
Yes.
So I'll take a break in the meantime, I take a coffee and come. Let them do the
Okay,
exercise.
sir. Okay, sir. This will be good.
sir. Null hypothesis, there is no association between the variables.
Housing quality and poverty level.
Yes, sir. Significance value 0.381 p value.
0.381 or 0.381.
0.381.
So what is your conclusion?
Therefore, null hypothesis is accepted.
0.3.
Yeah.
0.381.
Okay. Null is accepted.
Yeah, H naught is accepted.
So though there is no association between housing quality and poverty level. Okay.
Poverty.
Let me check. So what is the, let me share the screen. So what is the variable? First variable, housing quality, HQ, right? I'll write it for HQ housing quality, and then PL is poverty level. So 1 is low, 2 is high, let me say. 1 is low, 2 is high. Then similarly, poverty level 1 is low, I can copy this. Slow, 2 is high. So red of view,
Yes, sir.
red of view, third variable is count. So 1 comma 1, how many? Okay. 1 comma 1, 11, 4, 27, and 15. 11, 4, 27, and 15. 11, 4, 27, and 15. Great. That's it. Data weight cases. Because otherwise, SPSS won't be knowing. I have changed the format of the data. Okay. Now I have to analyze using crosstabs. I would like to take anything. In your case, what is that in the, nothing is there. So I can take anything in the row into columns. So analyze. Crosstabs. I'm taking housing quality into rows, into columns. Statistics, okay, size squared. What is this? You guys are getting 0.34, I'm getting 0.38. One, 2. So housing quality, low is 11, low, high is 4. Low is 11, low, high is 4. So all of you getting the same results like what I'm getting?
Yes, sir.
0.381.
Yes.
Right. So then null hypothesis getting accepted that there is no association between the variables. That's it. This is what chi-square test is. There are two types of chi-square test. One is goodness of fit and one is test of association. That's it. Now we are going to move to the remaining part of the non-parametric test. Remaining part of the non-parametric test goes like this. Yeah. Do you see a PPT?
Yes, sir.
Yes,
Okay.
sir.
This is
Yes,
the
sir.
complete non-parametric test. So one is test of relationship between variables. We have chi-square test, Spearman rank correlation test, binomial test, run test. Binomial test actually test, for example, in data you have a gender distribution. One denotes male and two denotes female. Is the proportion is equal? That is determined by a binomial test. And then run test is used for to find out whether the data is random, sample is random, whether it's coming from a random sample. That is run test. One sample case test is used to find out whether the data is normally distributed. And correlation, we have what is correlation coefficient? Correlation we have, and then when you have a rank data, we have a Spearman rank correlation. So these are all tests of relationship between variables, under which we have seen chi-square. Remaining, you can explore on your own. I'm just giving you an insight. Because of the time constraints and other things, we cannot do all the tests. So I'm just giving you the complete picture of what are all non-parametric tests available. We may not be doing all. I'm just giving you selectively, which is predominantly used. So chi-square is the predominantly used test of variable because it comes first, you see. And Spearman rank correlation also. But there are other tests also. I told you under which circumstances they are used. Binomial test is used, as I told you, whether the data is in equal proportion. For example, male is 50%, female is 50%. Housing quality data you have, 50% of the data is low housing, 50% of the data is high housing. That way, whether the distribution is equal, that you can test using a binomial test. A run test is used for whether the data is random. And then one sample case is Kolmogorov-Smirnov test is used for whether the data is normally distributed. Then you have independent samples. The test of differences between, this is test of relationship between variables. This is test of differences between the groups. Under which you have independent samples and dependent samples. Independent samples is actually two different groups. Is there a difference in the dependent variable based upon the groups? Dependent sample is like t-test, paired t-test. That is, sample is coming from the same respondents. So under the independent samples, if it is two variables, we will use Mann-Whitney U-test. If it is more than two variables, we will be using a median test and Crutchell-Wallis test. And in case of dependent sample, we will be using, in case of two variables, we will use Wilcoxon sign rank test. If it is more than two, we will use Kendall's W, Gobran Q, Friedman test, these are the tests. This is actually a complete picture of non-parametric test. But in our problems like marketing research or some of the research problems that we have, this will be the test mostly used. Even in the first session and the second session, there was a lot of queries about non-parametric tests. Here, there is a comparison between parametric tests and non-parametric tests. So you can take a snapshot of this. If you want, take a photo of this one. This will be very helpful to you. For correlation, in case of parametric data, we use a Pearson correlation test. But in case of non-parametric, we use Spearman rank correlation test. So when you compare independent measures of two groups, we use independent sample t-test. But if your data is of categorical nature, we will be using man-Whitney test. Similarly, if it is more than two groups, when you compare more than two groups, means we have used one-way ANOVA. Here we have Kruskal-Wallis test. And if the data is coming from the same sample over a period of time, we used paired t-test. In case of non-parametric, that test that we will be using is Wilcoxon test. And for repeated measures, that is data coming from, this is paired t-test is only 2 times, T1 and T2. If there is multiple times that data is taken, for example, time 0, time 1, time 2, time 3, time 4, then we use what? Repeated measures ANOVA in case of parametric and the Friedman test in case of non-parametric data or categorical data under non-parametric test. This is the broader classification. So let's look one by one. For example, independent measures, 2 groups and more than 2 groups. So I'm going to explain now man-Whitney test and the Kruskal-Wallis test. You guys are following me? Taken the screenshot of this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, here is the data. I'm sharing a data set called store.sav, under which what I have is design is one criteria, store size is another criteria. Sales is a rank data. Please understand this is not sales volume. If it is a sales volume, based upon the design, you got to compare the sales volume. If it is volume, you can use what? Independent sample t-test if you are comparing 2 groups. For example, group 1 and 2, is there a difference in the sales volume? You will be using independent sample t-test. But here, the sales is ranking. It is not the sales volume. Please understand. If it is sales volume in lakhs, then you can use what? Independent sample t-test. And if you are comparing all groups together, you use one-way ANOVA. But here, the dependent variable is ranking data. This is not the sales volume, that is continuous data. I just want to see whether the design is affecting the ranking. Is there a significant difference in the ranking due to design? So how to do that? How to do that? Analyze non-parametric test. You see that. See, whatever we discussed is here, chi-square, binomial, runs, one sample t-test. These are all what? One group. So this is what we are going to do, compare 2 groups, 2 independent samples. So 2 independent samples. So what is that? My dependent variable, test variable is sales. My grouping variable is design. My grouping variable is design. Then I have to define my group. So group 1 is 1, group 2 is 2. So I can compare any two groups between 1 and 2 or 2 and 3 or 3 and 4. But at any point of time, I can compare only two groups. Click continue, click OK. So what is the null hypothesis here? What is the null hypothesis? What is the null hypothesis here? There is no difference in the mean ranking. There is no difference. Our design is not influencing the mean ranking. No difference in the ranking due to the design. Our mean rankings are same. So null is getting accepted or rejected. You have to look at exact significant test. Asymptotic significant is useful for large sample size. Here our sample size is very, very small. So I have to use only exact significance, which is 0.548. So is there a difference in the ranks? What is the null hypothesis? There is no significant difference in the ranks due to the store design. Whether null is getting accepted or rejected? Since it is greater than 0.05, null is getting accepted. So our conclusion is your design is not influencing the ranking, or no difference in the ranks due to design. Is that clear?
Yes, sir.
So,
Yes, sir.
yeah, next. So what we have done is, man with me. Independent measure, independent sample t-test, and then equivalent non-parametric test is man with me test that we have done. We have compared two samples. That is store design 1 and store design 2. Is there a significant difference in the ranking? Just imagine if I have, rather than two designs, I have more number of designs, more number of stores I have to check. So naturally, if it is a continuous data, I'll be using one-way ANOVA. Remember some of the examples that we have discussed. A number of injuries that a team has sustained. We played against 4 different teams. A number of, when you play rugby against Japan or Togo, when you play against 4 different countries, what is the number of injuries sustained? So we compared more than 2 groups. At that point of time, we have used one-way ANOVA. The same is applicable for a non-parametric test. We call that as a Kruskal-Wallis test. So what is that? Here you are comparing the rankings, the mean rankings between more than 2 groups. It is happening more than 2 groups. For example, here earlier we have studied the difference between only 2 groups, 1 and 2. Is there a significant difference? We got our null hypothesis accepted that there is no difference in the ranking. Now let's see if we compare all the groups, is there a difference? So now non-parametric test, k independent samples. Why k independent samples? This is more than 2. Here in this case, k is 4. We have 4 different designs, and this 4 different designs, and then we have a sales ranking. We are going to compare, is there a difference in the sales ranking due to this 4 designs? So you see that Kruskal-Wallis is the default test. So sales is my test variable. Sales is my test variable. Store size is my manipulating variable. Defined range, minimum is 1, maximum is 4, because that is what the data. We have 4 different store designs, 1, 2, 4, 1, 2, and 3, and 4. So the minimum value is 1, maximum value is 4. Click continue and then click OK. So look at this. Here, what is the null hypothesis? There is no difference in the mean ranking. Your null is getting accepted. Or the right word that we're supposed to use, we are failing to reject the null hypothesis. Failing to reject the null hypothesis means that the mean ranking across the stores, which is having a different designs, are equal.
The screen stuck in PPT, sir.
So it means we have to do it again. Let me do it again. Can you see the screen now?
No, sir.
Now?
Yeah, sir.
Okay,
Yeah, visible, sir. Now it's
Guys,
visible.
visible.
I am selecting K independent samples. My test variable is sales. My grouping variable is store size. To define the range, minimum is 1, maximum is 4. Because that is what we have in the design. 1 is the minimum, 4 is the maximum. Continue. Okay. So you are seeing the output table, right? So now you are seeing the output. The null hypothesis, the mean rankings are equal. And you are looking at the significance. Asymptotic significance, it is 0.991, which is greater than 0.05. So you are failing to reject the null hypothesis, which means the mean rankings are equal. Once a week. Any clarifications?
No more.
So we are done with Mann-Whitney. We are done with Pascal-Wallis. So next we are looking at matched pair t-test. Equivalent of matched pair t-test for non-parametric is Wilcoxon test. We have that paired sample t-test, right? So in case of paired sample t-test, what is that we did? The data was coming from the same respondents, but at 2 different points of time. Similarly, here also the data is going to come from the respondents at 2 different points of time. But the difference is the data is going to be a categorical data or ordinal data. Either it is category or it is ranking. That is a challenge we have. So for that, I'm going to use a different status set. Let me stop share and share the screen. Yeah. So do you have a cancer data file that is visible?
Yeah, sir.
Yes.
Visible now, sir.
Yeah. So here the data is obtained from cancer patients in an hospital. So this is what the measurement that is taken at different time. Total C, total C, W2, W4, W6. There are multiple time period. It is actually measuring the condition of the patient. It's given us a ranking. They note the condition of the patient by some kind of rankings. This is initial. C in this initial, and then 2nd week, 4th week, and 6th week. This ranking is taken. This is a given ranking was given by doctors who's observing the patients. So Is there a significant difference in the rankings? That is what we are interested in. So if you are comparing only 2 weeks, it is paired t-test, similar to the paired t-test. So how you do that for a categorical data is analyzed. Parametric test. Under 2 related samples, you have Wilcoxon test. Wilcoxon is a default test. So what is that I'm interested in? I'm interested in, is there an improvement in the condition initial and the final? Is there a difference? It may be deterioration or it may be improvement. Both are possible. So what I'm looking at, is there a improvement? Is there a difference in the condition? It's not that I'm checking whether it is improvement or deterioration. I'm looking at, is there a difference in the initial condition and the final condition? So this is what the comparison. Simple, click OK. So the null hypothesis is there is no difference in the condition between the periods that is compared, initial and final in this case. So what happens? Your null is getting rejected. It is less than 0.05. So I can conclude that there is a difference in the condition of the patients. That is a difference in the conditions of the patient. So going back. So do we did one sample t-test? Yes. Under which one sample t-test? What we did? We compared against some value. Similarly, we can do that by chi-square test or one sample case test. When you for parametric data, when you do independent sample t-test, here for non-parametric we have man-Whitney use test. And then for more than 2 groups, for parametric data we use one-way ANOVA. Here we have Pascal-Wallis. And for repeated measures, we have paired sample t-test. The equivalent of paired sample t-test for non-parametric data is called Wilcoxon test. So what if in a matched pair t-test, the time period at which the data is compared only 2? What is if I am comparing multiple time period? Then I have to use Friedman t-test. Similarly, when the data is measured over a period of time, then I have to use one-way repeated measures. In fact, we have not discussed one-way repeated measures ANOVA. If you want, I can show you a sample of one-way repeated measures ANOVA and Friedman test. Do you want, Tirumal?
Sir?
Because we have not discussed one-way repeated measures ANOVA. You want me to show now what is one-way repeated measures ANOVA?
As you like it, sir. I'm not sure about it because I think we are running out of time, right?
Absolutely.
We have to complete by 11:45.
Right. Right. So I'll do only Friedman test. I'll explain what is Friedman test rather. Okay. So what is
then you have to handle the questions too.
Okay.
So it will take right.
So I'll just explain what is Friedman test and then we'll conclude.
Okay. Sir.
Then Friedman test, here earlier we have compared only 2 time periods. If you want to compare, is there a difference over the periods? Then I have to use Friedman test. What is that I have to do is K-related samples. And K-related samples, what is your test variable? Test variable is these 4. Let's take all 4. Click OK. So the hypothesis is there is no significant difference over the periods, but it tells that there is a difference over the periods. That is what the outcome of K-related samples. That's it, sir. from my side. So what is that we have seen? Van Whitney, Crutchell-Wallis, Wilcoxon, and Friedman. So I have given you, and that this is equivalent to which test under parametric. These are all non-parametric tests. These are all equivalent to this type of test which is being carried out under parametric. With this, I would like to conclude, Thermal. If there is any questions, I can take it up.
Definitely. We'll post for the questions.
Yeah.
Is that?
Yeah, sir.
Proceed with the questions.
Is there any questions? If at all any questions, I am ready to take.
No more, sir. Still no.
How many of the participants are alive? How many of them attending today?
100 plus, sir.
Yes.
Now it's 100 plus. When starting the session, 200 plus will be live.
So they are all aware that they will not get the certificate if they are not appearing for the test.
Hope so. But they are pretty enough in attending the assessment test, sir. I've got many questions.
Sir, question from Priya Chaudhary. Non-parametric test depends on sample size.
It is not depending on the sample size. It is depending on the nature of the data. If the data dependent variable is continuous rather than continuous, I mean, if your dependent variable is ordinal data or categorical data, you have to use non-parametric.
The next question from Naz, Saman Naz. Friedman test is used for scale data.
No, non-parametric test is not for scale data. If it is a scale data, you have to use repeated measures on over.
Any other questions, Nizar?
No more, sir. No more.
Right. I will make for. Sir, any briefing related to the past 5 days, sir? Any special comments from your side?
No, I don't have any.
Sir, you can moderate the questions and you can post it.
No
Soon
more
we will.
questions, sir. That's all.
Soon we will start our valedictory session.
Okay, sir.
The dean is supposed to join.
Okay, okay. Sir, some participants said, ask, can you suggest SPSS books?
There is a SPSS book by Andy Field, but there is no Indian edition. It is a costly book. It's a UK based guy. The good textbook is Doing Data Analysis Using SPSS by Andy Field. ANDY, Andy Field, FIELD.
Sir, any foreign author, sir, Indian author?
No.
So we are at the end session. Thank you one and all for your patience. Thank you, Dr.M.Sivagnanasundaram, for your informative sessions for the past 5 days. And I would like to invite our beloved Dean, Dr. T. Senthil Kumar, to give his valedictory address. Sir, you may proceed.
Most respected, our resource person, Dr. M. Sivagnanasundaram, Associate Professor, MIT Hyderabad, and then Head of the Department, Dr. M. Ravichandran, and then Organization Secretary for this event, Dr. C. Tiruchirappalli, and faculty members from NBA, and all the participants from 5 days webinar. Good morning to one and all. I'm very happy to conclude this meeting.
Sir, video not available, sir.
I think there is a strong streaming problem.
Streaming problem, I think so. I think there is a streaming problem, sir. Let us see whether it's continuing it or not. There?
Yeah, sir.
Sir, வந்து தமிழ் செந்தில் குமார்னு வரும்.
Okay.
நீங்க அந்த வீடியோ மட்டும் மறுபடியும்
joining.
Yes,
sir, you can proceed.
Sorry for network, network problem. I'm happy to say that in the MBA department started in the year 2008 with the MBA program alone. Now 9 full-time regular faculty members, all are qualified with excellence level. It's happy to say everyone have a doctorate. The great asset of the department is alumni. Most of the old students are settled in occupying the key position in public and private sector, as well as a multinational company, not only domestic, but also foreign countries. The department gives more attention rather than make people to be entrepreneur rather than the employee. This department has conducted many national and international seminar and conference and workshop. This is the first webinar. This is the first webinar conducted by the department. I wholeheartedly congratulate the both coordinator and head of department. I wholeheartedly, on behalf of Honorable Vice Chancellor and Registrar and Dean, as of my own behalf and faculty members, I thank our webinar resource person, our resource person from hello, I'm audible?
Sir, yes, sir. Sorry.
Hello.
Yes, sir.
Dr. M. Sivagnanasundaram, Associate Professor. I wholeheartedly thank you, sir, for participating in this function. And I thank you in the great manner. I thank our wholeheartedly for everyone to present my validity address. Thank you once again for giving the opportunity to share some of my in August. Thank you.
Thank you, sir. Thank you very much.
Thank you so much.
So thank you, one and all.
Thank you.
Thank you, one and all. And let me finish this 5-day webinar by posting my vote of thanks. Formally, starting with, I would like to thank our Honorable Vice Chancellor, Professor M.K. Surappa, Dr. L. Karunamurthy, Registrar, Dr. S. Seladurai, Additional Registrar, for their enormous support to conduct this webinar in a grand success. And I would like to say my heartfelt thanks to Dr. T. Sedil Kumar, our beloved Dean, for his tremendous support in executing this type of online workshops. And I would like to say my sincere thanks to Dr.M.Sivagnanasundaram, Associate Professor, IMT, Hyderabad, for his consideration in executing these 5 days webinar. Thank you, sir. Thank you. Thank you very much. And I would like to say thanks to Dr. M. Ravichandran, the head of the department, and our technical team, my dear faculty members, Dr. S. Saravanan, Dr. B. Kishori, Dr. K. R. Mahalakshmi, Dr. G. Balamurugan, Dr. S. P. Dandayadapani, Dr. M. Robinson, Dr. V. M. Anita Rajati for their tremendous support. And I think if I have not say thanks to my dear friend who have the backup for this webinar, Dr. A. Nirmal Raj, HOD of Savita Engineering College, Chennai, who have actively backed up for our webinar and for the grand success for the past 5 days. And from student coordinators, I would like to say my sincere thanks to Mr. Vidyadharan, the second year MBA student, who have been continuously supporting for this webinar success, and Mr. Uzair Nizar Rahman from Savita Engineering College for his technical support in moderating the questions and for backing up with his technical skills for the success of this webinar, data analysis using SPSS. And I will never be good enough to say just thanks to the participants, because we got a very good support from you. Tremendous registrations, but we have limited to 250 plus in order to focus this webinar for students and research scholars alone. So definitely we will come back for faculty too. Thanks for your wonderful support. So after this session, you will get very soon the feedback form as well as the assessment test form through your group, WhatsApp group. You please be with us in submitting the feedback form and assessment form. And you will get your certificates only if you have cleared your assessment tests, as well as if you have attended all the 5-day sessions. Thank you one and all. Thank you to all people who have directly and indirectly supported us for the success of this webinar. Once again, for the participants, for the resource person, for the technical team, for our faculty members, for each and everyone, a very big thanks from our department side. Thank you one and all. And now we close our session. Thank you.
Thank you very much. Thank you, everyone. See you.
Sir, Siva sir,
Yeah.
the participants who are all in Zoom,
Okay.
they want to share some feedback to you.
Okay.
Sir, first you should close YouTube live.
Live.
I closed.
Oh, it's going on still.
No, it's still going on, sir.